Good day, math learners! I'm back. In this topic, we will discuss about theoretical and experimental probability. Before we go on to theoretical and experimental probability, things you need to know. There are three properties of probability. These properties will help us to solve the likelihood of an event to happen. These are the properties of probability. First, 0 less than or equal to the probability of event less than or equal to 1. The probability of an event must be a number between 0 and 1 inclusive. Next property is the probability of the impossible event, and that will be equal to 0. The probability of an impossible event to happen is 0. Example, the probability to snow in the Philippines is 0 because here in the Philippines we cannot experience snow. That's why the probability is 0. Probability of a certain event, and that will be equal to 1. Example, the probability of getting a real number in a die game is 1. That's why it's equal to 1. Now let's go on to theoretical probability. When we say theoretical probability, it's the ratio of a number of favorable events to the total number of outcomes, or just simply number of ways divided by the possible outcomes. So this will be N quantity E represents the number of ways event E can occur. And quantity S represents the number of possible outcomes in the sample space S. And PE represents the probability of event E to happen. Now let's have an example. Determine the probability of the following events. Number 1. When a fair die is rolled once, what is the probability of A. Getting 7. B. What is the probability of getting an odd number? C. What is the probability of getting a 5? And letter D. What is the probability in getting not a 5? Let's solve for letter A first. Solution. So the formula for our probability of event is that will be the number of ways over the number of the total number of possibilities. So NE is equal to 0 because the faces of die do not have 7, or the dice don't have 7, right? So the total faces of a die is equal to 6. So our NE is 0 and our NS is 6. 0 divided by 6, and that will be equal to 0. So our probability of 7 is 0. For letter B, same formula. Our NE is equal to 3 because obtaining an odd number has 3 outcomes. What are those odd numbers? That will be 2, 4, 6. Okay? I mean 1, 3, 5. Those are odd numbers. And NS is 6 because the total faces of a die is 6. Remember, the total faces of a die is 6 only. So 3 over 6. Simplify. 3 over 6, when we simplify that, that will be 1 over 2. Therefore, there is 1 over 2, or 50% probability of getting an odd number in rolling a die. For letter C, what is the probability of getting a 5? Okay, NE is equal to 1 because there's only one outcome of getting a 5. Remember the property? In a rolling a dice, there's only one outcome of getting a 5. That's why our NE is equal to 1. And NS is 6 because total faces of a die is 6. So that will be 1 over 6. Therefore, there is 1 over 6 or 16.67% probability of getting 5 in rolling a die. For letter D, getting not a 5. What are the probabilities in getting not 5? So NE is equal to 5 because there are 5 outcomes of getting not 5 because 6 is the total faces. So getting not 5, so 5 uh, will cancel out. So the remaining is 5 number outcomes. That will be 1, 2, 3, 4, and 6. So that's why 5 outcomes. So our NE is 5 and the total faces is 6 for NS. So 5 over 6. Then our final answer is 5 over 6. Therefore, there is 5 over 6 or 83.33% probability of getting not 5 in rolling a die. Experimental probability. When we say experimental probability, it's the ratio of the number of times the event occurs to the total number of trials. It refers to the probability of an event occurring when an experiment was conducted. Probability of event is equal to the number of times the event occurred over the number of trials. Okay, please take note for that. Okay, example. Find the experimental probability of the given event. The given situation is if a die is rolled 100 times. So a die is rolled 100 times. And the number 3 occurs 12 times. What is the experimental probability that 3 shows up on a die? So the number of times the event occurred. Okay, take note. Over the number of trials. That will be the formula in getting the probability of event. So there are 12 times the event occurred and a 100 total number of trials. Diba? Remember? So 12 is the number of times the event occurred, and for the number of trials, which is 100. So 12 divided by 100, when we simplify that, we divide both sides by 4, and that will be 12 divided by 4, that will be 3. 100 divided by 4, that will be 25. Therefore, our answer is examples, another one. For number 2, if a marksman hits the target 95 times, and misses 5 times, what is the experimental probability of his scoring a hit? So, if we yes, what you observe in the given problem, a marksman hits the target 95 times, but he misses out 5 times. Okay, so number of times of the event occurred and the number of trials. So there are 95 times the event occurred, 95 times, because that's the time he hits the target. And 100 total number of trials. Why is it 100? 995 times he hits the target, but he misses 5 times also. That's why 95 plus 5, that will be 100 as a total number of trials. That will be 95 over 100. 95 over 100, when we simplify that, that will be 19 over 20. For number 3, a coin is tossed 60 times. So 60 times. The head appeared 45 times. Find the probability of getting head in this experiment. Okay, what is the probability? So simply 45 is the event occurred, and 60 is our number of trials. Therefore, 45 divided by 60. Then simplify. 45 divided by 60, when we simplify that, that will be 3 over 4. Thanks for listening. Don't forget to answer the given formative assessment.